Hi, welcome to my channel. In this video, we want to solve the following problem. Given convex quadrilateral ABCD, let E and F be points on AB such that AE equals 2EF equals 3BF, and G and H be points on CD such that CG equals 2GH equals 3DH. Join E to H and F to G. Given that area of ABCD equals 121, the goal is to find area of EFGH, which is the area of this blue region. And now for the solution. First, join A to H, H to F, and F to C. Now, consider triangle EFH and triangle AFH. They share the same height H from H to AB. So area of AFH equals half times H times AF, and area of EFH equals half times H times EF. Taking the ratio, area of EFH over area of AFH equals half times H times EF over half times H times AF. Half times H cancels, giving area of EFH over area of AFH equals EF over AF. This is the key idea. Triangles with equal heights have areas in the same ratio as their bases. Since AE plus EF equals AF and AE equals 2EF, we get 2EF plus EF equals AF, or 3EF equals AF. So EF over AF equals 1 over 3, and therefore area of EFH over area of AFH equals 1 over 3. Next, consider triangle GHF and triangle CHF. They share the same height L from F to CD. So, area of GHF over area of CHF equals GH over CH. Since CG equals 2GH, we have CH equals CG plus GH, which equals 2GH plus GH, which equals 3GH. Thus, GH over CH equals 1 over 3, so area of GHF over area of CHF equals 1 over 3. Now, area of EFGH equals area of EFH plus area of GHF. Also, area of AFCH, which is the area of this red region, equals area of AFH plus area of CHF. From the ratios above, we have area of AFCH equals 3 times area of EFH plus 3 times area of GHF, which equals 3 times area of EFGH. Therefore, area of EFGH equals 1 over 3 times area of AFCH. Next, join A to C and then consider triangle AFC and triangle ABC. They share the same height G from C to AB. So, area of AFC over area of ABC equals AF over AB. Now, AB equals AF plus BF. Since 3EF equals AF and 2EF equals 3BF, we get AB equals 3EF plus 2 over 3EF. So, AB equals 11 over 3EF. Thus, AF over AB equals 3EF over 11 over 3EF. Hence, AF over AB equals 9 over 11. Therefore, area of AFC over area of ABC equals 9 over 11. Next, consider triangle ACH and triangle ACD. They share the same height J from A to CD. So, area of ACH over area of ACD equals CH over CD. Since 3GH equals CH and 2GH equals 3DH, we get CD equals CH plus DH, which equals 3GH plus 2 over 3GH, which in turn equals 11 over 3GH. Thus, CH over CD equals 3GH over 11 over 3GH, which equals 9 over 11. Therefore, area of ACH over area of ACD equals 9 over 11. Now, area of ABCD equals area of ABC plus area of ACD. Also, area of AFCH equals area of AFC plus area of ACH. Using the ratios above, we have area of AFCH equals 9 over 11 times area of ABC plus 9 over 11 times area of ACD. Therefore, area of AFCH equals 9 over 11 times area of ABCD. Area of EFGH equals 1 over 3 times area of AFCH, and thus equals 1 over 3 times 9 over 11 times area of ABCD, which in turn equals 3 over 11 times area of ABCD. Since area of ABCD equals 121, area of EFGH equals 3 over 11 times 121. Therefore, area of EFGH equals 33, which is the answer. As an exercise, try to solve this problem and see if you can get the correct answer. This marks the end of the video. If you enjoyed this video, please leave a like and subscribe to my channel for more content. Thanks for watching and see you all next time.